Good day, class. In this video, I will going to discuss laboratory exercise number 2, that is compression test. This will serve as your guide in performing your laboratory exercise number 2. As you perform this exercise, you will be able to examine the behavior of the specimen that is subjected to compressive stress. Next, you'll be able to apply the simulation features in SolidWorks in performing the compression test. And lastly, you will be able to interpret the result of the simulation for compression test. So for this typical compression test, our simulation tool is the SolidWorks simulation software. To begin with, you need to open the SolidWorks simulation software. So as shown on the screen, this is the SolidWorks software environment. The first thing that you should do is go to the menu bar, then click this new icon, then choose part, and then click OK. For our compression test, we have two parts. The first one is the die, and then the second one is the specimen. So the die is the one that exerts compressive force to our specimen, and our specimen is the one that receives the compressive force. And of course, it creates, no, as we apply a compressive force. So the middle part of our specimen will create a bulge due to the compressive stress. So let's start by making the die. So we are going to create our sketch on the top plane. So click the top plane icon and then select the sketch icon. So the top plane will automatically display normal to the working area. So for our die, the shape will obviously be a cylindrical um, body. So to create a cylindrical body, or to create the um, cross-sectional sketch, so on your keyboard, press the S button and then select this circle icon. We need to create the uh, the cross section of our die. So from the origin as the center, and then click anywhere, and after that press S button again, or the S key, and then select the smart dimension icon, and then click the circumference of the circle, and then make the diameter of this circle equal to 50 mm, and then press enter, or you can also click this check icon. Next, we are going to add some volume to our die. So click this one and then go to features and then select extruded boss or base, and then change the direction of the extrusion. We're going to make this downward, and then the thickness of our die will be 30 mm. Then press enter, so the preview will appear, and then press OK. So this is now the final appearance of our die, and the next step is to save our model. So click this save icon, and then let's rename this one as die 2 because I already made uh, the die here. So we need to rename it on another file name. So that is die 2, then save. Next, you can also close this one and then click the new icon, then select the part, then click OK. So this time we are going to create our specimen. So first we need to make a sketch. Go to the top plane, then select sketch, and then make a circle. So press the S key, then select the circle icon, then create a circle with a diameter of 30 mm. So this is 30 mm, and then click OK, and then go to features, select extruded, and then change the direction of the extrusion to downward, and then input the depth of extrusion that is equal to 60 mm, then press enter and then click OK. This is now our specimen model, and then the same with the die. We are going to save this one, so click the save icon, then input the name of this model, so specimen number 2, because I already created the specimen before. So let's change the file name. Okay, after this one, um, we are going to assemble these two components. So go to the new icon and then press the new icon and then select the assembly, then click OK. So you have to wait, no, because the system will load out, and then here we're going to begin our assembly. So we need to select the model that we're going to put in our assembly. So we have here the specimen 2, but if this specimen 2 does not appear in this box, so click this this icon, browse icon, and then select the model that you want to assemble. So select the specimen, then open. So the specimen will appear on the working area, and after that go to assembly, and then insert a new part. Sorry, so insert components and then click browse, and then we are going to insert the die. Okay, right here. Now we are going to add some mate for our models. So first click this mate icon, then click the cylindrical surface of our specimen and also the cylindrical surface of our die, and then the relation would be concentric. Then press or click OK. So the first relation is that our specimen, our die, should be concentric with each other. And then next, we're going to add one more relation. That is, we're going to coincide the surface, the bottom surface of our die, and the upper base of our specimen. So to do that, select the bottom surface of our die, and also select the upper base of our specimen. After that, it will automatically select the type of mate that is coincident, and then click OK. So there you have it. We have just established the mates for our assembly, and then click OK. Next, we are going to activate the simulation feature. So go to SolidWorks add-ins. Now in my case, I've already activated the simulation feature, so I will turn it off, and then I will reactivate this one. Okay, so let's continue. There are two ways to activate the simulation feature. The first one is by browsing the SolidWorks add-ins tab. So within this tab, you can find the SolidWorks simulation icon. So you can click this one, and then it will load for some time. So be patient lang. Okay, so you can um, you can determine if the SolidWorks simulation has been activated because the icon will be highlighted. Okay, so the second way of activating the simulation software is by clicking the option icon, and we have here a drop down arrow, and under the drop down arrow, select add-ins, and there is a dialog box. So under this dialog box, check the SolidWorks simulation as well as the startup, and then press OK. So that's the other way of activating the simulation feature of the SolidWorks software. So once you activated the simulation feature, so go to the simulation tab. So under the simulation tab, we are going to set the simulation, the type of simulation that we are going to perform. So we have here a drop down arrow, and then select new study. Under new study, so the type of study for compression test is nonlinear. So click this nonlinear option, and then select static. In the previous video, for tensile test, we select dynamic. But for compression, the ideal type of nonlinear study is the static. So after pressing static, click OK. So you can also see that under our status bar, we are now on the simulation mode. So we are already through with the model or the 3D views mode. Now under the simulation study, so we have here some properties that we need to update and to modify. So the first thing is the material for each model. So let's start with the die. So in the die, so click the die icon, and then right click, then choose apply or edit material. For our die, we are going to apply SolidWorks DIN materials. Under this folder, select the tool making, DIN steel tool making, and then select 1.2083, then 42 x42 cr13. So click this one, and then this dialog box will show the mechanical properties of this material, and then next is click the apply button, and then close. So you can also verify if the material has been applied to your model right here. No, so for our die, the type of material is DIN 1.2083 X42 CR13. Next, we are going to apply a material for our specimen. So right click specimen, select apply edit material, and then for our specimen, we're going to assign SolidWorks DIN materials and then select structural, and then under the structural folder, select 1.0044 S275JR, and then the dialog box will appear for this type of material, and then change the model type. Instead of linear elastic isotropic, select plasticity von Mises. This is the ideal model type for our compression test. So these are the mechanical properties of our material. Afterwards, click apply and then close. So it will automatically update the material for our specimen. Now for the connections, we do not modify this part because we already set the mating properties of our model. So let's proceed to fixtures. Under fixtures, we are going to apply a fixed geometry. Now for compression test, we want the base of our specimen to be fixed. So under this box, so click this one, means that this surface will be fixed during simulation or during the test. Afterwards, click OK. Then we still need to add another fixture. So right click fixture and then go to advanced fixtures. Under advanced fixtures, select on cylindrical faces, and then select the cylindrical surface of our die. So for compression test, we are going to move this die, no, towards the specimen um, in order to execute the decompression. So for the movement of this die, we only restrict its movement along the axis of our specimen. That is, there is no radial movement as well as rotational movement. We only have translational movement, and we set our translational movement to be 20 mm. And for its direction, so for the compression action, we want the direction to be towards the specimen. But currently, the direction of our translation is going upward, so we need to reverse the direction. So click this box, and then it will automatically update the direction of our motion, which is towards the specimen. And afterwards, click OK. Next is we're going to assign the mesh. So just skip the external loads we uh, because we don't want to have an external load for our test. So go directly to the mesh, right click, and then create a mesh for our model. So click this mesh parameters and change the type of mesh from standard mesh to curvature based mesh. This is the ideal mesh type for our test. Then click OK. So the appearance of our model changes from the 3D view, the normal 3D view, to the meshing view. So you can see the the model was divided into finite elements. Afterwards, uh, we are going to run the simulation. So under this nonlinear one default option, right click and then select run. So there's a dialog box with this message. So ignore this one by clicking OK. And then there you have it. So the simulation now started, and currently we have a memory usage of 290, almost 300 kilobytes, and the elapsed time is 30 seconds. By the way, I forgot to um to change the study properties. So let's cancel this one first. So yes. So for this study, you need to modify the study properties. So go to study advisory. We have here a drop down arrow. So click this one and then choose study properties. Now under the nonlinear static dialog box, kindly check this option. We have large strain option because we considered that the 20 displacement is already large for our model. It's already um, a large value for our model. So select this one or check this option and then change the type of solver, because for nonlinear study, the ideal solver could be direct sparse solver or large problem direct sparse. So select this large problem direct sparse and then click OK. Afterwards, we are going to run this simulation again. So click this nonlinear one default option and then right click and then run the simulation. So ignore this dialog box, ignore this message, and then our simulation has already started, and the memory usage is around 500 kilobytes and the elapsed time is uh, 20 seconds. So I will going to update you every 20% of the simulation progress. We are now 11.5% of our simulation progress. This is now the appearance of our die and the specimen. There are some changes with the color assignments at some areas of our specimen. So the color indicates the magnitude of the stress that is being experienced by our specimen. The elapsed time is 23 minutes. So the next update will be the next 20% of our simulation progress. We are now at 22.6% of the simulation process. Okay, it's already 25.0%, and this is now the appearance of our specimen. So I will update you if the simulation process will reach to 50%. We are now 55.7% of our simulation process. The memory usage increases to 2000, I mean 2 million kilobytes, and the elapsed time is 53 minutes and roughly 20 seconds. This is now the appearance of our specimen. and then the next update will be at 80% of the simulation process. So here's an update. We are now 82.2% of our simulation process, and this is now the appearance of our specimen. So my last update will be at the termination point of our simulation process. So try to observe some features that has changed during the simulation process. Okay, so we are now 100% of our simulation process, and this is now the final appearance of our specimen. As you notice, there are some changes with respect to the shape and geometry of our specimen. And as you can see, there are some black lines near the base of our specimen, and it is probably uh, some cracks that propagates at the or near the base of our specimen. Now this time we are going to investigate each of the three simulation results. We have the stress, the displacement, and the strain. So at the moment, or as you can see in the working area, this is the stress result. Now I will going to rotate our model so that you can see the effects of decompression. Now for this simulation result, we can change some properties. So to include or change some properties, right click this stress one von Mises option, and then select chart options. Now under chart option, we can show the maximum stress of our specimen as it undergoes compression. So show maximum annotation. Okay, so you can also move this one. So the maximum annotation, or I mean the maximum stress, is experienced in this location. Then click OK. Now we are going to create an animation for the first result. So right click stress option and then select animate, and under the animation setting, so let's stop this animation first. We need to save this one. We need to input first, or we need to indicate first the path of our video file. So click this button, and then I'm going to put it under laboratory exercise number 2. So this is animation for stress result. Then press enter. So here we are going to click this play button, then it will slowly animate the model. So try to observe what happens as the specimen is compressed by this die. So afterwards it will load for some time because the software is still generating the video file. Okay, the video file was already generated, so you can click OK, but you can also hover this one. So let's try to change its viewing angle. Okay, I think that's enough, so click OK. Now let's proceed to the second result, which is the displacement. So click the displacement option, right click, and then select show. So this time the uh, the appearance of the model changes because this one is for the displacement. Now let's animate this one. So select animate. Okay, right click displacement, select animate, and then it will animate the system. So try to observe and try to investigate what happened as the specimen is compressed. Okay, so let's try another viewing angle. Say this one. So let's say let's start the animation. So this is the front view of our model. Notice that our specimen is gradually compressed. Okay, then click OK to end the animation. So let's proceed to the final simulation result, which is the strain. So click the strain, right click, and then show. This is now the corresponding appearance for the strain result. Now let's animate this one. Okay, so right click and then select animate. So this is the animation for the strain. So try to observe so that um, you have or you can have the idea that you will be able to draft the contents for your discussion. Then click OK. Now for this test or for this simulation, you can also generate a result, and with your result you can also insert or you can also include some image. Just click this icon, include image for report, and then you may select the current view, or you can also um, import some image file. So for this video, I'll just select the current view. So this current view will be included in your report. So click OK, and after that the result options will appear under this tab on the left. And to generate the report, so right click this result option icon, and then define or edit the material. Okay, just cancel out. I think this one, sorry, not the result option but the report. So right click this report icon and then define. So just wait for a while. Now this is the dialog box for the report options. Now under this section, These are the contents of the report. You can also input the name of the designer, the company, the URL, the logo, and the address, as well as the phone and the fax information. So for this, you can also change the path of your file. So I'll change this one. I will put it under desktop and under MEng113, MEng143 subject, under laboratory exercise number 2, then OK. Next, we're going to change the paper size from letter to A4. And then lastly, we're going to apply these changes and then publish. Once published, so the software will generate the report of this simulation. So it will take for a while. So be patient na lang. So it will take for some time to generate the report. Okay, this is now the Word file for the simulation result. So we have here the title of the simulation, and these are the contents, starting with the assumptions, followed by the mechanical properties or the study properties. We have here the mesh type, the start time and the end time, the time increment, and we also have the units during the simulation. And as you can see in this table, it shows the material properties of our model. The first one is the die, highlighted in blue, and the second one is our specimen, the same thing, highlighted in blue. Next are the loads and fixtures and the displacement. And then next is the mesh information. So we choose solid mesh, and the measure is curvature based mesh. The total nodes is displayed in this table. This is the appearance of our model when it undergoes the meshing process. And then finally, these are the study results for the stress. So this is the final appearance of our specimen subjected by compressive stress. At the next, this is for the displacement, and for each result, the table shows the type of the test and also the minimum and maximum values for each parameters. So here is the strain result, and then this one is the image that we have just included, no, in the SolidWorks software. So if you want to include multiple images, so you can also do that one. Just um, just perform those process several times. Okay, so that's it for this video. I hope you learned something with regards to compression test using this simulation tool, which is the SolidWorks software. So thank you, and may God bless you.